when we speak of Kirchoff's laws, we have the first law and we have the second law, and these laws basically deals with currents. So I would take you through the two laws and break it down for you to really understand it. Now let's take the first law for instance. So Kirchoff's first law. Well, this law, which is mostly called the current or point law, current or point law. Point law actually states that the sum of currents arriving at the junction in an electrical network is equal to the sum of currents leaving the junction. So let's take this diagram for an example, right? So we have this diagram, and let's say we have one arrow pointing down, right? If the arrow is pointing down, then it means this is the junction, right? So this current is coming to the junction. But the law states that the current coming to the junction is equal to the sum of the currents leaving the junction. So let's give this arrow, and then this also another arrow, right? So it means let's name this current 1, I1, this current 2, and then we give this current 3, right? So we can say that this current, which is 1, is equal to the current leaving the junction. So the current 1, this current arriving at the junction here, leaves through this path. So we can say that current 1 is equal to the I2, which is the current 2, this current leaving that junction, plus this current also leaving that junction, which is I3. So the first law of Kirchoff, or Kirchoff's first law, actually talks about this. This is basically what it means. So the current coming to the junction, right, is equal to the current leaving the junction, right? So that's what basically it means. Okay, now let's look at this. Now let's look at the second law, right? The second law, that's Kirchoff's second law. Yeah, and this law actually, it talks about, it says that in a closed loop of an electrical network, the algebraic sum of the EMFs is equal to the algebraic sum of the potential differences. So let's say this is our circuit, right? This is our electrical circuit. We have this here, for example, and we have this. Okay, let me clean here. Okay, we have this here also, for example. So we have one here, and we have this here, right, and this here. So let's say this is where the power is from. We have one current direction here, and let's give here A, here B, and here C, and here D, right? So the direction of the current means it's going this way, so it's going this way, right? Goes this way. Okay, so as I mentioned earlier, it states that the algebraic sum of the EMFs is equal to the algebraic sum of the potential difference. So we have here, let's say this is our R1, this is our R3 or R2, right? So R1, R2, R3. Okay. So this law is just saying that when you add the EMFs, it should be equal to what? The algebraic sum of the potential difference. So, okay, so EMF, the sum will be equal to what? The algebraic sum of the what? The potential difference, right? Okay, and this, right, is what we would say is equal to, using the diagram, we would say this E, right, is equal to I, this I here, I, and then the first R, so R1 plus this same I goes through the whole circuit, so it will come here to the R3, and it's the same thing that will come to the R2. So we'll say I R2 plus that same current will go through the R3, so I R3. So basically, the Kirchoff's second law talks about the movement of the current through the circuit and the encounter it has with the resistance, the R, right? So this I here will pick this R to form IR1, and then it will come here to meet this to give us IR3, and it will come here to meet this to give us what? IR2. So we add this, and this, and that's what the second law basically what talks about. I hope this was helpful, and I would be glad if you subscribe to our channel. Thank you very much for watching.